So here's a typical problem. A plane contains the following points A, B, and C. There are three possible questions they might ask. They might ask, find the vector equation of a plane. We talked about this earlier. This is where you do OP equals OA plus TAB plus SBC. They also might ask you to write the parametric equation of the same plane. That's where you take the vector equation of the plane and break it down into the parametric equations x equals, y equals, and z equals. The third possible question is they might ask you to find the rectangular equation of the plane using the normal vectors. Well, we have to think back on normal vectors. If I'm given 3 points in space, how would I find a normal vector? So if we think back to normal vectors, we have 3 points A, B, and C. Before we talked about vectors AB and vectors AC. Can you remember how we found the normal vector? What would we do to find this normal vector? That's right, we would find the cross product. So think back on how you would find the cross product given these 3 points. So in order to do the cross products, we have to find the vector AB and the vector AC. We do terminal minus initial for AB and terminal minus initial for AC. So go ahead, press pause, and do that. Okay, so here are the 2 vectors, AB and AC. I wrote them one on top of the other so it's easier to find the cross product. Just imagine putting I, J, and K right at the top. Go ahead, find the cross product. Remember, when I find the cross product of these 2 vectors, that's going to give me the normal vector. So I did the cross product of AB cross AC, and I got this normal vector, 30, negative 35, negative 5. If you didn't get this answer, double check how you're doing the cross product, watch out for those negatives, and maybe review the cross product YouTube video. So remember our initial goal. Our initial goal was to find the equation, the rectangular equation of the plane using normal vectors. So we started with these 3 points. We found the cross product. We got a normal vector. This normal vector is perpendicular to not only the 2 vectors AB and AC, but it's also perpendicular to the plane, which includes vectors AB and AC. So there's the plane. And the normal vector is perpendicular to the plane. So we're now back to find an equation of a plane given a normal vector and given a point in the plane. Remember, they actually gave us 3. So now I can choose whichever point I want, plug that in, and remember that's going to give me the D. So go ahead, set up your equation for the plane using A, B, and C from our normal vector. Then plug in X, Y, and Z from one of the points, and that's going to give you your D. So go ahead, press pause, try it. So here's your final answer. Your final answer, you get 30x minus 35y minus 5z equals 50. This is the equation of the plane, which contains these 3 points. This is the rectangular equation of the plane because we have Cartesian x, y, and z. So that's a third possible way that they might ask this question. Given 3 points, find the rectangular equation of the plane.